Okay, thank you. I'm very pleased to offer you my perspective on the relevance of geologic maps to societal issues, including perhaps planning and execution of lunar explorations. To give you some sense of my background and priorities, the first part of my research mapping and USGS career focused on making regional and national map compilations and applying geologic information to societal issues, earthquake hazard mitigation, groundwater vulnerability, that sort of thing. In 1995, I was asked to define and build the congressionally mandated National Geologic Map Database in cooperation with the state surveys. Next slide, please. So here's the site. Next slide, please. The Geologic Mapping Act of 1992 authorized the Geologic Mapping Program, and the purpose of the act was to build this National Geologic Map Database. And that database, the mandate included development of technical and science standards. Next slide, please. For example, the FGDC cartographic standard for geologic map symbolization. There is a section on planetary geologic features. It's probably out of date and could use your updating, and paper copies are still available. Next slide, please. The other standard that the project NGMDB has been heavily involved in is development of a standard schema for the GIS database that represents the geologic map. This is published. It's the standard schema now for several of the USGS funding programs and the state surveys. I've talked with Jim Skinner and others. Lunar maps certainly could be in GEMS. There's no reason why it couldn't be. It's the same. They're all geologic maps. Next slide, please. You might be interested in the GEMS geomaterials hierarchical classification. Initial maps of planetary bodies might show map units in the upper part of the hierarchy. It's quite a nested hierarchy of about 6 levels. Field observations then would enable more precise descriptions of the geologic units. It's intended to be a very simple, roughly 100 unit classification for common display of many maps using the same very simple classification. So you might find that useful. Next slide, please. This is our map viewer showing the San Francisco Peak area north of Flagstaff. It's a quick reminder of the many maps that have been made and the fact that they all follow the same fundamental principles. It was mentioned earlier that geologic map is an iterative process. That very much is true. Initial geologic studies of an area tend to be regional and reconnaissance in nature, to be followed by updated maps that after more field observations and interpretations are made. Reconnaissance maps guide the data gathering, the observations and interpretations that lead to creation of better maps to inform land use and other applications. And further, these updated maps may be regional or they may be focused on a very detailed area. And I'm not telling you anything you don't already know. Next slide. So this is a close-up of a map from one of the nation's first geologic reconnaissance expeditions. That is the Hayden survey. It was one of 4 pre-USGS surveys of the Western US. It was done to explore the landscape, identify resources. Perhaps it's rather like a map of the moon before you land. Very, very simple, very straightforward, based on a basic understanding of the geology, but also of the landforms. Next slide, please. So this is the same area after a century during which observations and new geologic theories were developed. Again, mapping is an iterative process based on field observations and geologic interpretation. Next slide, please. That principle continues to be applied as new societal issues arise. An area that might first have been mapped for mineral potential, such as this Indian Hills quadrangle in Colorado, they might later be reinterpreted for land use applications or to identify natural hazards. Next slide, please. So this is the same map that was interpreted a few years later for engineering purposes. Basically, the topology is the same, the map units are the same, but the the descriptions, the explanation, the classification are different. They're geared towards engineering purposes with an eye towards land use development and hazards mitigation as opposed to resource potential. Next slide, please. So when seeking to explain how geologic maps are useful, I turn to publications like this one, Interpretive Geologic Maps for Engineering Purposes. The authors took a geologic map, presented the earth materials in several different ways to help people address issues such as digging a foundation, and you'll see these in the map preview. Digging a foundation, availability of construction materials, where to find a water supply, and how rocks affect decisions on siting a road or dam. Next slide, please. This is the geologic map. By the way, it's part of the Geologic Atlas of the United States Folio series. Began under Director John Wesley Powell, and many of the map standards we use today were developed then. These are the folded rocks of the Appalachians in Pennsylvania. Next slide, please. Now here's a piece of that geologic map reinterpreted and presented so that information about foundation and excavation conditions are highlighted. On Earth, the iterative mapping process may take decades to occur, but for mapping of the moon, those iterations can of necessity be compressed into a near real-time process. The geologic map units and other characteristics as shown on the reconnaissance geologic map, which is compiled from interpretation of remotely sensed data, will, when examined in person during a lunar transect, likely need to be somewhat refined or reinterpreted. Those revisions to the geology can be used to quickly update the geologic map and any derivative maps, such as the nature and thickness of unconsolidated materials or the suitability for vehicular movement. That in turn could enable traverse routing and site sampling procedures to be modified, optimizing the time spent and the information collected. The same can be said of military geology maps and their derivative maps that were made prior to U.S. reoccupation of Pacific Islands during World War II. Reconnaissance maps and descriptions were made at that time, but surely strategies were adjusted during the military operations. The maps and descriptions were then further modified for later use by the U.S. in rebuilding or expanding island infrastructure. I've seen declassified documents prepared for those reoccupations and compared them to maps and reports, such as we'll see in the next few slides. Next slide, please. This is the cover page for one of the military geology reports that were written in the years following World War II. This is of the Truk Islands, a 262-page report with 50 maps, prepared by USGS for the Corps of Engineers. We tracked down 26 of these gray literature reports, scanned all the text in the maps, and they're on the site for you to see. They clearly illustrate the importance of the geologic materials, not only for military purposes, but also for infrastructure development. Next slide, please.
2 minutes.
Thank you. Next slide, please. So this is the geologic map of Guam from that series of reports. The next slide will be a section on the eastern shore of the island. Next slide, please. Okay, so this is a zoom in of the geology. The next slide, you'll see, I know this, I'm saying next slide, but anyway, the next slide is suitability for cross-country movement. Let's show that next slide, please. So the geology was just reinterpreted for areas that are passable, impassable in different conditions, the slope and the surface. And that was accompanied by a map showing suitability for amphibious landings. Next slide, please. So I hope you're seeing kind of a parallel between these military geology maps, the derivative maps based on the geologic maps, and how the geologic maps can change over time as well, as something that might be relevant to your work. Last slide, please. So I tend to end with this. This is a Director John Wesley Powell. His point was that the maps that we make, the work that we do, need to be understandable, not just to geologists, but to the people who are going to use the maps, the taxpaying public, but also other professionals, in this case, perhaps astronauts. And that in addition to making them simple and understandable, that we make them available to people in a very quick, concise, easy to navigate system of websites so that people can get to the information quite easily. So thank you.